Please subscribe our channel for latest updates. In this session, we learn about multiplication of decimal numbers. Now discuss about the multiplication of decimal numbers. For example, multiplication of 0, 1 with 0, 1. Here 0, 1 and 0, 1 are the two decimal numbers. Before do the multiplication of these decimal numbers, consider the numbers without decimal numbers. That is 0, 1 and 0, 1. The 0, 1 and 0, 1 can also be written as 1 and 1. After multiplying 1 with 1, we get the product 1. This is the actual multiplication of the numbers. We already know about it. Next, if we multiply the decimal number 0, 1 with the decimal number 0, 1, we get the product 0.01. This is because number of digits after decimal point is 1, and here also number of digits after decimal point is 1. Total together we have 2 digits. So in product we keep the decimal point from right to left after 2 digits. Now consider example 2 for the explanation of multiplication of decimal numbers. Here multiply 2.5 with 1.25. First consider the numbers without decimals to the multiplication of decimal numbers 2.5 with 1.25. That is, we multiply 25 and 125. 25 into 125. If is 25, 5 2s are 10, 10 plus 2, 12. Carry 1, 5 1s are 5, 5 plus 1, 6. Next, 2 5s are 10, 2 2s are 4 plus 1, 5, 2 1s are 2. So by adding we get 5, 2 plus 0, 2, 5 plus 6, 11. Carry 1, 2 plus 1, 3. So we get product 3125. So by multiplying the decimal numbers 2.5 into 1.25, we get 3.125. It is because the number of digits after decimal in the first decimal number is 1, and in the second decimal number of digits after decimal point is 2. So total together 3 decimal points in the product. So we can keep the decimal point from right to left after 3 digits. Now we solve the try this page number 50. There are 2 problems given in this try this. First one is find the product of the given decimal numbers. There are 3 bits are given, and in second question it is given arrange the product of obtained in 1 in descending order. First we solve the first problem. In that one it is given that 2.7 into 4. We have to find here the product of 2.7 into 4. So to find this one, first we multiply 27 with 4. So 4 7s are 28, 4 2s are 8, 8 plus 2 10. So product is 108. Here in the decimal number we have 1 digit after decimal point. So in the second number we not have any decimal point. So in product we keep the decimal point from right to left after 1 digit. So we get the answer 10.8. Next we find the product of 1.8 into 1.2. To find this one we first multiply 18 with 12. So 12 adds 96. So 12 ones are 12. 12 plus 9 is 21. So we get the product 216. So by observing the given decimal numbers, we have 1 digit after decimal point. In second decimal number also we have 1 digit after decimal point. So in product we have decimal point after 2 digits. So from right in product we keep the decimal point after 2 digits. Now we find the product of 2.3 and 4.35. To find this one, first we multiply 435 with 23. 3 5s are 15, 3 3s are 9 plus 1, 10, 3 4s are 12 plus 1, 13. Now multiply with 2, 2 5s are 10, 2 3s are 6 plus 1, 7, 2 4s are 8. By adding we get 5, 0, 7 plus 3, 10, carry 1. So 8 plus 1, 9, 9 plus 1, 10. So we get the product 10005. In first decimal we have one digit after decimal point, and in this decimal number we have two digits after decimal point. Total we have 3 digits after decimal point in a product. So we keep the decimal point from right to left after 3 digits. Next, second question. It is given that arrange the products obtained in question 1 in descending order. So products in above problem are 10.8, 2.16 and 10.005. Descending order means large to small. So by observing these two, so 10.8 is greater than 10.005 and this is greater than 2.16. Now we solve example 7, page number 50. In this problem it is given that the side of an equilateral triangle is 3.5 centimeters. Find its perimeter. We already know that the equilateral triangle means whose each side is have the same length, that is each side of the triangle is 3.5 centimeters. So perimeter of the equilateral triangle is equal to 3 into side. Here side is, each side is 3.5 centimeters. So we multiply 3 into 3.5. To do this multiplication, first we multiply 35 with 3. 3 5s are 15, 3 3s are 9, 1 plus 10. So we get 105. So in given decimal, we have one digit after decimal point. So from right to left we keep the decimal point in a product. Therefore perimeter of equilateral triangle is called 10.5 centimeters. Now we solve example 8, page number 50. In this example it is given that the length of rectangle is 7.1 centimeters and its breadth is 2.5 centimeters. What is the area of the rectangle? So we have to find the area of the rectangle from the given problem. So here the length of the rectangle is equal to 7.1 centimeters given and the breadth of the rectangle is equal to 2.5 centimeters given. Therefore we can write length of the rectangle is equal to 7.1 centimeters and the breadth of the rectangle is equal to 2.5 centimeters. We already know that the area of the rectangle is equal to length into breadth. So here length we can write 7.1 centimeters into breadth is 2.5 centimeters. So to find this product, first we multiply 71 with 25. So 5 1s are 5, 5 7s are 35, 2 1s are 2, 2 7s are 14. By adding we get 5, 7, 7, 1. So we get product 1775. By multiplying centimeter into centimeter we get centimeter square. In the given decimal 7.1 we have one digit after decimal point, and in 2.5 decimal we have one digit after decimal point. So together we have 2 digits after decimal points. So in product we keep from right to left decimal point after 2 digits. So area of the rectangle is equal to 17.75 centimeter square. Now we discuss some examples about multiplication of decimal numbers by 10, 100 and 1000. For example, we multiply 1.76 with 10, which can be written as 176 by 100 into 10. Here in denominator we get the 100 because in the given decimal number we have 2 digits after decimal point. By cancellation we get 10 ones are 10, 10 tens are 100, which can be written as 176 by 10. 176 by 10 can be written as 17.6 because in denominator we have 1 0, so we keep the decimal point from right to left to after 1 digit. Next, second one example, we multiply 1.76 with 100, which can be written as 176 by 100 into 100. In denominator we have 100 because in given decimal number we have 2 digits after decimal point. By cancelling 100 ones are 100, 100 ones are 100, which can be written as 176, which can also be written as 176.0. Next, third example, we multiply 1.76 with 1000, which can be written as 176 by 100 into 1000. In denominator we write 100 because in given decimal we have 2 digits after decimal point. By cancelling 100 ones are 100, 100 tens are 1000, which is equal to, we can write it as 176 into 10, which is equal to 1760. From the above example, simply we can say that when we multiply a decimal number with 10, we shift a decimal point to one place to right, and if we multiply a decimal number with 100, we shift the decimal point to two places to right, and if we multiply decimal number with 1000, we shift the decimal point 3 places to the right. Now we discuss some more examples about multiplication of decimal number by 10, 100 and 1000. For example, we multiplication of 2.35 with 10, we can write it as 23.5. Because when multiplying 2.35 with 10, we have 1 0 here, so we shift decimal point to one place to the right, so we can write it as 23.5. Next example, we multiply 2.35 with 100, so it can be written as 235.0. because when multiplying 2.35 with 100, in 100 we have 2 zeros, so we shift the decimal point to the 2 places to right, so it can be written as 235.0. Next example, we multiply 2.35 with 1000, so it can be written as 2350.0, because when multiplying 2.35 with 1000, here we have 3 zeros, so we shift the decimal point to 3 places to the right. Here we not have sufficient digits, so we take one more 0, so we get 2350.0. Now we consider another example about multiplication of decimal number by 10, 100 and 1000. In this example, we multiply 12.356 with 10, so it can be written as 123.56, because when multiplying 12.356 with 10, here we have 1 0, so we shift decimal point one place to the right, so we can write 123.56 after multiplication. Next example, we multiply 12.356 with 100. It can be written as 1235.6, because when we are multiplying 12.356 with 100, here we have two zeros, so we shift the decimal point to the two places to the right. So we can write 1235.6 in product. Next example, we multiply 12.356 with 1000, so we can write 12,356.0, because when we multiply 12.356 with 1000, here we have three zeros, so we shift the decimal point to three places to the right, so we can write 12,356.0 in product. Now we discuss one more example about multiplication of decimal number by 10, 100 and 1000. Here we multiply 0.5 with 10, which can be written as 5.0, because when we multiplying 0.5 with 10, here we have one zero, so we shift the decimal point to the one place to the right. So in result we can write 5.0. Next example, we multiply 0.5 with 100, so we can write 50.0, because when we multiplying 0.5 with 100, here we have two zeros, so we shift the decimal point to the two places to the right. Here we have only one digit, so we write another digit in the result, so we can write 50.0. Next we multiply 0.5 with 1000, so we can write it as 500, because when we multiplying 0.5 with 1000, here in 1000 we have three zeros, so we shift three places to the right, so here only one digit, so we add another two zeros to get a result. From the above we can conclude that when a decimal number is multiplied by 10, 100 or 1000, the decimal point in the product is shifted to the right by as many zeros as. We further discuss more examples. Here we multiply 0.07 with 10. It can be written as 0.7, because when we multiply 0.07 with 10, here we have one zero, so we shift the decimal point to the one place to the right, so we can write it as 0.7 as a result. Next we multiply 0.07 with 100. It can be written as 7.0, because when we multiply 0.07 with 100, here we have two zeros, so we shift the decimal point to two places to the right, so it can be written as 7.0. Next example, 0.07 into 1000 can be written as 70.0, because when we multiply 0.07 with 1000, Here we have 3 zeros, so we shift the decimal point to the 3 places to the right. Here we have only 2 digits, so we write another digit extra, so we get 70.2. Now we solve, try this page number 51. In this one, first we solve the first bit. Here given 0.3 into 10, so this can be written as 3.0, because we know that when we multiply 0.3 with 10, we have 1 0, so we shift the decimal point to the one place to the right, so we can write it as 3.0. Next we find the product of 1.2 with 100, so it can be written as 120.0, because when we multiply 1.2 with 100, here we have 2 zeros, so we shift the decimal point to the 2 places to the right, so we can write 120.0. Next we multiply 56.3 with 1000, so we can write it as, here we have to multiply 56.3 with 1000. After multiplication we get 56,300.0, because when we multiplying 56.3 with 1000, here we have 3 zeros, so we shift the decimal point to 3 places to the right, so here we not have sufficient digits, so we add more 2 zeros to the result, so we can write it as 56,300. Now we are going to solve exercise 2.6 problem 1. In first problem there are 7 bits are given. First we solve the first bit. Here we have to find the product of 0.2 and 6. To find this product, first we multiply the numbers without a decimal point, so we multiply 6 with 2, 6 2 is 12, we get the product 12. To find the position of decimal, first we find the position of a decimal point in 0.2 is 1 digit after decimal point. In 6 we not have any digit after decimal point, so together we have 1. So from right to left we keep the decimal point after 1 digit. Next we find the product of 8 and 4.6. To find this one, first multiply the numbers without a decimal point, so 46 into 8, 8 6 48, 8 4 32, 32 plus 4 36, we get the product 368. So in 8 we not have any digit after decimal point. In 4.6 we have 1 digit after decimal points. Together we have total 1 digit after decimal point. So in result we from right to left we keep the decimal point after 1 digit. Now we find the product of 2.71 into 5. To find this one, first we multiply 271 with 5. 5 ones are 5, 5 sevens are 35, 5 twos are 10, 10 plus 3 13. We get a product 1355. So in 2.71 we have 2 digits after decimal point. In 5 we not have any digit after decimal point. So together we have 2 digits after decimal point. In product from right to left we keep the decimal point after 2 digits, we get 13.55. Next we multiply 20.1 and 4. To find this product we multiply 201 with 4. 4 ones are 4, 4 into 0 0, 4 twos are 8. We get 804 as a product. 804. So in 20.1 we have one digit after decimal point. In 4 we not have any digits after decimal point. So together we have one digit after decimal point. In product from right to left we keep the decimal point after one digit. So we get 80.4. Now we find the product of 0.05 and 7. To do this first we multiply 5 with 7. 7 5s are 35. So we get the product 35. So in 0.05 we have two digits after decimal point. In 7 we not have any decimal point, so we have 0 digits. So total we have 2 digits after decimal point. In result from right to left we keep the decimal point after 2 digits. So we get the answer 0.35. Next we multiply the 211.02 into 4 to find this product. We multiply 21102 with 4. 4 2s are 8, 4 into 0, 0, 4 1s are 4, 4 1s are 4, 4 2s are 8. So we get the product 84408. So in 211.02 we have 2 digits after decimal points. So in 4 we not have any digit after decimal point. So we get 2 digits after decimal point. So in result from right to left we keep the decimal point after 2 digits. Next we find the product of 2 and 0.86. To do this we multiply 86 with 2. So 2 6 are 12, 2 is 16 plus 1 17. So product is 172. So in 2 we not have any digit after decimal point. In 0.86 we have 2 digits after decimal points. Together we can write 2. So in product from right to left we keep the decimal point after 2 digits. So we get the result 1.72. Now we solve the second problem of exercise 2.6. In this problem it is given that find the area of the rectangle whose length is 5.7 centimeters and breadth is 3 centimeters. First we draw the rough sketch of rectangle. It is given that the length of the rectangle is 5.7 centimeters and the breadth of the rectangle is given 3 centimeters. So from the problem we can write length of the rectangle is equal to 5.7 centimeters and breadth of the rectangle is 3 centimeters. We already know that the area of rectangle is equal to length into breadth. So we substitute the length value 5.7 centimeters and breadth value 3 centimeters. And we find the product. Multiply 57 with 3. So we get 3 7s are 21, 3 5s are 15 plus 2 17. So we get total product of 171 centimeter into centimeter. We can write as a centimeter square. In the given decimal 5.7 we have only one digit after decimal point. So in product from right to left we keep the decimal point after one digit. Therefore we can write area of a rectangle is equal to 17.1 centimeters. Now we find the solution of the third problem. In third problem there are total 12 bits are given. So first we find the solution of first bit. Here we have to find the product of 1.3 into 10. So we already know that if we multiply with 10, shift the decimal point to one place to the right. So in product we can write 13.0. Next second one 36.8 into 10. Here also we have 1 0. So we shift the decimal point one place to the right side. So then we can write 368.0. Next here have 1 0. So we shift the decimal point one place to the right side. So we can write 1537.0. Next, here we are multiplying with 10, so it have 1 0. So we shift the decimal point to one place. So we can write as 1680.7, nothing but 1680.7. So here we multiplying with 100. So we shift the decimal point to two places. So here we not have two digits, so we keep 1 0 in place of second digit. Then we get 3110.0. That is, we get 3110. Next, here also we are multiplying with 100. So we shift the decimal point to the right by two places. So in resultant, we write 15610 because we write a 0. We not have here two digits after decimal point. Here also we are multiplying with 100, so we shift the decimal point to the two digits to the right. So it will become 362.0. In eighth bit we have to multiply 43.07 with 100. So in 100 we have two zeros. So we have to shift decimal point to the two places to right. So it can be written as 4307.0, nothing but 4307. Next, we have to multiply 0.5 with 10, so it have only 1 0. So we shift the decimal point to the one place to the right. So it can be written as 05.0. It is nothing but 5.0. Next, 0.08 into 10. Here we have only 1 0, so we shift the decimal point to the one place to the right. So it can be written as 0.8. It is nothing but 0.8. So next, 0.9 into 100, it has two zeros, so we shift the decimal point to the two places. But here we have only one digit, so after 9 we keep another 0. So it can be written as 090.0, which can also written as 90.0. So next, 0.03 into 1000. Here we have three zeros, so we shift the decimal point to the three places to the right. So it can be written as 003. After 3 we add another 0, so we keep point. So it can be written as 30.0. Now we solve the third problem of exercise 2.6. In this problem there are 12 bits are given. First we solve the first bit. It is given that 1.3 into 10. Here we have only 1 0. So we shift the decimal point to right by one place. So we can write it as 13.0. Next we saw second bit. It is given that 36.8 into 10. Here also we have only 1 0, so we shift the decimal point one place to the right. So it can be written as 368.0. Next, 153.7 into 10. Here also we have only 1 0, so we shift the decimal point to the one place to the right. So we can write it as 1537.0. It is nothing but 1537. So next, 168.07 multiply with 10. So here also we have only 1 0, so we shift the decimal point to the one place to the right. So we can write it as 1680.7. So next, 31.1 into 100. Here we have two zeros, so we shift the decimal point to the two places to the right. Here we have only one digit. After 1 we keep another 0. So we can write it as 3110.0, nothing but 3110. Next 156.1 into 100. Here also we have 2 zeros, so we shift the decimal point to the 2 places to the right. So here we have only one digit after decimal, so we keep another 0 after 1. So we can write it as 15610.0, nothing but 15,610. Next 3.62 into 100. Here we have 2 zeros, so we shift the decimal point to the 2 places to right, so we can write it as 362.0. Next 43.07 into 100. Here we have 2 zeros, so we shift the decimal point to the 2 places to the right, so it can be written as 4307.0. Next we multiply 0.5 comma 10, so we have only one 0 in multiplication, so we shift the decimal point to the 1 places, so we can write it as 5.0. Next 0.08 into 10. Here we have only one 0, so we shift the decimal point to the only one place to the right, so it can be written as 0.8. Next we have to multiply 0.9 with 100, so here we have 2 zeros, so we have to shift the decimal point to 2 places to right. Here we have only one digit, so we keep the extra 0 after 9, so it can be written as 90.0. Here we have to multiply 0.03 with 1000. Here we have 3 zeros, so we shift the decimal point to 3 places to the right, so we have only 2 digits, so we keep one extra 0 after 3, so it can be written as 0030.0. It is nothing but you can write it as 30.0. Now we are going to solve the fourth problem. In the fourth problem, it is given that a two-wheeler covers a distance of 55.3 kilometers in 1 liter of petrol. How much distance will it cover in 10 liters of petrol? So from the given problem, we can write the distance covered by two-wheeler in 1 liter of petrol is equal to 55.3 kilometers. So we have to find the distance covered by the two-wheeler in 10 liters of petrol, which is equal to, I can write it as 10 into 55.3 kilometers. We already know that when we multiply with 10, we shift the decimal point to the one place to the right side, so we can be written as 553.0 kilometers. So in 10 liters of petrol, two-wheeler covers 553 kilometers. Now we solve the fifth problem. In fifth problem, there are 10 bits are given. So first we find the product of 2.5 into 0.3. To find this product, we multiply numbers without a decimal. So multiply 25 with 3. 3 5s are 15, 3 2s are 6 plus 1, 7. We get 75. Here in 2.5 we have only one digit after decimal point. In 0.3 we have only one digit after decimal point. So together we have 2 digits after decimal point. So in product from right to left we keep the decimal point after 2 digits. So we get 0.75. Now we find product of 0.1 and 51.7. To find this product, we multiply 517 with 1. So we get 1 7 the 7, 1 1 the 1 5 is a 5. So we get the product 517. So in 0.1 we have 1 digit after decimal point. We have in 51.7 we have 1 digit after decimal point. So together we have 2 digits after decimal point. In product from right to left we keep the decimal point after 2 digits. Next, find 0.2 into 316.8. To find this one we multiply 3168 with 2. So 2 8s are 16, 2 6 are 12 plus 1 13, 2 1s are 2, 2 plus 1 3, 2 3s are 6. So we get a product 6336. So in 0.2 we have 1 digit after decimal point. In 316 point we have 1 digit after decimal point. Together we have 2 digits after decimal point. So in product from right to left we keep the decimal point after 2 digits. Next we find 1.3 into 3.1. To find this one we multiply 13 with 31. So 1 3s are 3, 1 1s are 1, 3 3s are 9, 3 1s are 3. By adding we get 3, 9 plus 1 10, carry 1, 3 plus 1 4. We get product to 403. So in 1.3 we have 1 digit after decimal point. In 3.1 we have 1 digit after decimal point. So together we have 2 digits after decimal point. In product from right to left we keep the decimal point after 2 digits. So we get 4.03. Now we find 0.5 into 0.05. To find this product we multiply 5 with 5. 5 5 is 25. We get the product 25. So in 0.5 we have 1 digit after decimal point. In 0.05 we have 2 digits after decimal point. So we together have 3 digits after decimal point. In product from right to left we keep the decimal point after 3 digits, but here we have only 2 digits, so we keep the 0 and keep the decimal point. So we get 0.025. Next we find 11.2 into 0.15. To find this product we multiply 112 with 15. So 5 2s are 10, 5 1s are 5, 1 plus 1 6, 5 1s are 5, 1 into 2, 2 1 1s are 1, 1 1s are 1. By adding we get 0, 6 plus 2 8, 5 plus 1 6 1. We get the product 1680. So in 9.2 we have 1 digit after decimal point. In 0.15 we have 2 digits after decimal point. Together we have 3 digits after decimal point. So in product from right to left we keep the decimal point after 3 digits. So next we find 1.07 into 0.02. To find this one we multiply 107 with 2. 2 7s are 14. 2 into 0 0 plus 1 1. 2 into 1 2. We get 214 as the product. 114. So in 1.07 we have 2 digits after decimal point. 0.02 we have 2 digits after decimal point. So total together we have 4 digits after decimal point. In product from right to left we keep the point after 4 digits, but here we have only 3, so we keep the 0 here and keep the decimal point. So we get the 0.0214. Now we find 10.05 into 1.05. So to find this one we multiply 1005 with 105. 5 5 is 25. 4 into 0 0 plus 2. 2 5 into 0 0 5 1 5. 0 into 5 0. 0 into 0 0 0 into 0 0 into 1 0. Next 1 into 5 5 1 into 0 0 1 into 0 0 1 into 1 1. By adding we get 5 2 5 5 0 1. So we get the product 1 0 5 5 2 5. In 10.05 we have 2 digits after decimal point. In 1.05 we have 2 digits after decimal point. So together we have total 4 digits after decimal point. So in product from right to left we keep the decimal point after 4 digits. Next we find 101.01 into 0.01. To find this one we multiply 10101 with 1. So we get 1 into 0 0 1 into 0 0 1. So we get the product 10101. So in 101.01 we have 2 digits after decimal point. In 0.01 we have 2 digits after decimal point. So altogether we have 4 digits after decimal point. In product from right to left we keep the decimal point after 4 digits. So here we get 1.0101. Now we find 100.01 into 1.1. To find this one we multiply 10001 with 11. 1 1 1 into 0 0 1 into 0 0 1 into 0 0 1 1 1. Next 1 1 1 1 into 0 0 1 into 0 0 1 into 0 0 1 1 1. By adding we get 1 1 0 0 1 1. So the product is 110.001. In 100.01 we have 2 digits after decimal point. In 1.1 we have 1 digit after decimal point. So together we have 3 digits after decimal point. In product from right to left we keep the decimal point after 3 digits. So we get 110.011.